Here we're going to talk about compound inequalities. Now, when graphing compound inequalities, we'll be dealing with two different types. The first type is the inequality joined by the word and. We're talking about just the word and. This type of renders a solution of a set of values greater than a number and less than a number. So and is the key word here, and it looks something like this. A, or any variable, but A in this case, less than X is less than B. In this case, we want values for which both inequalities are true. A is less than X and X is less than B. We can think of our solution as everything in between the two numbers A and B. The second type of compound inequality is the type joined by the word or. Here our solution is a set of values greater than a number or less than a number. So it looks something like this. Maybe X is less than A or X is greater than B. Okay, so in this case we want values for which the variable in at least one of the inequalities is true. It doesn't have to both be true, but that's why we have or right here. This can be true or this can be true, so we want one or the other. So let's look at a few examples of these, and let's go ahead and graph these examples. So we have the compound inequality minus 1 is less than X, and X is less than or equal to 4. Okay, and we want to graph this thing on a number line. So let's go ahead and draw our number line. And let's go ahead and put 0 in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we want to graph this thing, and X is going to be, this is an and problem. X is going to be between minus 1 and 4. So if we think of everything between A and B, we're thinking of everything between minus 1 and 4. And we always want to make sure that we pay attention to the signs. This is a less than or equal to sign, and this is a less than sign. So we're going to look something like this. This is minus 1, and this is 1, 2, 3, 4. All right, we can fill out the other ones in a little bit if we want to. So we're going to have an open parentheses here and a closed bracket right here. All right, and we're going to shade everything in between. Now, a hint, whenever we're dealing with an and or something that looks like this, a compound inequality, we're going to shade in one interval. All right, because everything is going to lie in between minus 1 and 4. All of our x values are going to lie in this interval. But we're not including minus 1 in the interval, but we are including 4 in the interval. That's why we have a bracket here. All right, let's do a few more of these just so we can get a better understanding. Let's say we have the following compound inequality. We have x is less than 2 or x is greater than 6. The or tells us that we have we're going to have our compound inequality is going to be split up on the number line. So let's see what that looks like. Here's our number line. Here is, let's just go ahead and put 2 here, 3, 4, 5, 6. All right, and this goes off in the negative direction. Okay, so we want all the values that are less than 2 or all the values that are greater than 6. So both of these are less than, or neither of them is less than or equal to or greater than and equal to, so we're actually going to use parentheses here. So we're going to shade all the values that are less than 2, and we know how to do that. Without including 2, we put a parentheses opening to the left, and we shade to the left. We want all these values to represent this inequality. This part of the compound inequality is all the values of x that are greater than 6. So this is going to have an open parentheses to the right, because we're not including the 6. We're including all the values to the right of 6. So this makes sense. A compound inequality, all it simply is two inequalities. If it's an and problem, where we're looking for all of the values in between two numbers, where x lies, it's going to be simply one interval. If we're looking for if we have an or problem, we're going to have two separate inequalities shaded on a number line. So if we think about it, it's kind of intuitive and it does make sense. So let's look at the next one. Let's say we have the compound inequality x is less than or equal to 0 or x is greater than 3 over 2. Let's go ahead and graph this one. Don't worry about if you're looking for applications or what this is used for. We'll do applications in a little bit. Right now we want to just get a good idea of what these actually mean and how we graph them. So -1, or +1. Okay, so we're looking for all the values that are less than or equal to 0. So we're going to shade to the left of 0, but we're going to include 0 in our interval. So we're going to put a bracket right here and shade to the left. Now we know we're going to have two different shaded areas here because it's an OR problem, so we're going to have two different regions. The second region is all the values that are greater than 3/2 or 1/2. 1/2 is somewhere right about here. So we want to shade all the values to the right of 3/2 with a parentheses at 3/2. So that will be right here, and we'll shade all that. Okay, so that goes to positive infinity. This goes to negative infinity. There's actually only this little area that's not lying in our interval. All right, let's do a couple more. Let's take a look at the compound inequality -3 less than or equal to x less than or equal to -1. Get familiar with the and compound inequality because you'll actually be seeing that much more in higher mathematics. You don't see this much, but especially in calculus, you'll deal with this notation quite extensively. So let's look at that, see what it looks like on a number line. So we have, let's put 0 here, 1, 2, 3, 4, so we have -3, -1's here. Okay, we don't need to fill in the rest. All right, so we're looking for all our values. We can say from this compound inequality, we can say all our values lie in between -3 and -1. Okay, so there's nothing to the right of -1 or greater than -1 that lies in this interval, as nothing to the left or nothing less than -3. So we want all the values to the right of -3. X is greater than or equal to -3 if you look at this part backwards. So we're going to put a bracket here and shade to the right. Now before we do that, since we're only going to have one interval like this one, we want to know how far we want to shade. We look at the other part of the compound inequality. All of our values for x are going to be less than or equal to -1, so they're not going to go past -1. So we're going to put a bracket right here and we're going to shade to the left. All right, now the key here is we only shade what's in between these two brackets. So we're just talking about this area right here. So we don't want to make one bracket and shade everything to the right, make another bracket and shade everything to the left, because then our whole number line is going to be shaded and it's going to look a mess. If we do that, it might be messy, but there we can actually see where they overlap. If we shaded everything and it overlap in this little section here. But it looks a lot better and a lot nicer if we do it like this. So let's look at the next one. We have x is less than -2, or x is greater than or equal to 5. Let's go ahead and graph this compound inequality. This goes out to negative infinity. This goes out to positive infinity. Let's put 0 in the middle. This is 5. Here's -2. Okay, so we're going to have two different shaded regions here because we have an OR. This is an OR problem. So we want all the values for x that are less than -2. So we're going to shade to the left of -2. We're not going to include -2 because it's just less than. So we put a parentheses here and we shade to the left. Now we want all the values that are greater than or equal to 5. We're going to shade all the values to the right of 5, but we're going to include 5 in our solution set, so we'll put a bracket here and shade to the right. All right, so once we get an understanding of what's going on here, there's really not much to these problems. All right, let's do another one. Let's take a look at the compound inequality 7 is less than or equal to x, and x is less than 10. That's technically how that's read. And let's see what that looks like on a number line. Let's go ahead and put 7 here. Here's 10 and a couple over here. Okay, so this is 4 right here. We'll just make a few points. Okay, so we want all of the values for x that are in between 7 and 10. So all the values that are greater than 7 are going to be shaded to the right. This is going to include, our interval includes 7 because it's less than or equal to x. So we include a bracket here, and we're going to open up to the right. Sometimes it does help if you break it up and just read this part of the compound inequality as x is greater than or equal to 7, and then x is less than 10. I always like to have x moving from left to right. It just makes more sense to me. And then we have, before we shade that, since we're going to be overlapping here in one region, let's go ahead and see what the next part has to offer. We know we're shading to the right of 7, we just don't know how much. So we're looking for all the values of x that are less than 10, not including 10. So all the values to the left of 10, putting a parentheses there. And now we're just going to shade the region in between. All right, let's make a little space for one more. We're going to do an actual, a quite popular problem, one that you're going to see, especially in calculus. You're going to see in trigonometry. You're going to see it extensively. So I just want to get you familiar with it. This one is, we have -1 is less than x is less than 1. Okay, these are actually less than and equal to signs. Okay, so -1 is less than or equal to x, which is less than or equal to 1. Now this describes all sort of phenomena, but it's actually in particular sine and cosine functions. These are trigonometry functions, and this describes the range of a sine and a cosine function. So let's go ahead and see what it looks like on a number line. So we have this going into negative infinity, this going into positive infinity. We have 0 here, -1 and 1. Okay, so this is red, x is greater than -1. So we want to bracket at -1 because it's included in their solution interval. And we're going to shade to the right. Now before we do that, we look at x is less than or equal to 1, a positive 1, including 1. So we're going to put a bracket, we're going to shade to the left. All we simply do is shade between the intervals, or between the brackets. So this is the interval we're talking about. And when we're dealing with sine and cosine, when we get up into trigonometry and calculus, we'll see that the value never oscillates. It'll oscillate indefinitely in between -1 and +1, but it'll never go outside these two boundaries. This is very helpful if you're going into engineering and any sort of higher mathematics to know. So we'll look at a few more examples. In the next section, we'll actually be given a number line or the solution graph, and we're going to write the compound inequality. We're going to go in the other direction. So very fun. We're getting to a lot of exciting stuff using compound inequalities. I'll see you in the next video.